Hello, welcome to the Calm Universe channel. Here the stories are slow, long and calm. Before we begin, take this moment while you're still awake to subscribe and like this video. In a few minutes, your mind will be traveling through stars, planets and the sounds of distant rain. Now simply settle in, close your eyes, breathe slowly, and let's get to today's story. Good night. On Earth, rain begins in silence. It forms high above the ground, where warm air rises and meets cooler layers of the atmosphere. The moisture carried upward condenses into tiny droplets, too small to fall, suspended by invisible currents of air. When enough of these droplets gather, they combine and grow heavy. Then, under the quiet direction of gravity, they begin their long descent toward the ground. It is a simple process, guided by physics and temperature, repeating endlessly without interruption. Every drop that falls completes a cycle that began as vapor, returned as liquid, and will rise again in time. The rhythm of rain is the same everywhere on the planet. It begins with evaporation, the slow lifting of water from oceans, rivers and soil. The heat from the sun gives energy to the molecules, allowing them to escape the surface and move upward. Higher in the atmosphere, where the air is cooler, the energy is released and condensation begins. The process does not hurry. It follows balance, turning warmth into motion and motion into rest. From the outside, clouds appear to drift without purpose, but within them, billions of droplets form, collide, and merge in an endless pattern of creation and fall. As the droplets grow, their weight overcomes the small upward movements of air and they begin to fall. Each drop follows its own path, drawn by gravity, passing through layers of temperature and humidity that shape its form. Some evaporate before reaching the ground, returning quietly to the sky. Others fall completely, touching leaves, roofs and soil, where they collect again. The sound of rain, the soft repetition of drops against the earth, is the audible trace of this movement. It is not random noise, it is the sound of equilibrium. Heat turning to motion, motion turning to rest. From the ground, rain seems like a surface event, a change in weather that comes and goes. But it is part of a system that never stops. Even when the sky is clear, evaporation continues. Even when no cloud can be seen, water vapor moves through the air, invisible but constant. The earth breathes through this cycle, releasing moisture and drawing it back in, maintaining balance between ocean, land and atmosphere. It has been doing so for billions of years, and it will continue long after human observation ceases. The planet's calm persistence is what keeps the air breathable and the surface alive. In this cycle, there is no beginning and no end. Each droplet of water has existed in many forms. It has been vapor in the sky, liquid in a river, ice in a glacier, and part of a living cell. The boundaries between these forms are temporary. Rain is simply one phase, the transition between invisible and visible, between sky and ground. The molecules themselves are ancient, following the same natural laws that govern stars and gravity. Their motion through the water cycle is slow on the human scale, but continuous on the planetary one. The temperature, the pressure, and the density of the air determine how the rain behaves. In warm climates, droplets remain small and light, falling like mist. In colder regions, they freeze and return as snow, each flake a slow geometric pattern of water, arranging itself according to the rules of crystallization. In some cases, Rain passes through layers of air with different temperatures, changing from liquid to ice and back again before touching the ground. The process adjusts itself automatically, always seeking balance, always responding to the energy around it. If one were to observe rain without emotion, it would appear as a stable pattern. Countless small bodies moving downward through air at different speeds, merging, dividing, and evaporating. The motion of each droplet is governed by drag, by surface tension, by gravity, and by the turbulence of the wind. These forces act in harmony, creating a natural rhythm that repeats wherever there is atmosphere and water. It is not chaotic. It is ordered, though too complex to notice in detail without instruments. The repetition of rain is the repetition of the planet's need for stability. In scientific terms, the rain cycle is part of the hydrosphere, the global system of water exchange between Earth's surface and its atmosphere. It connects every ocean, river, cloud, and glacier. Energy from the sun drives the cycle, but gravity completes it. Without gravity, vapor would rise and never return. Without heat, water would remain still. The cooperation of these forces allows the rain to exist, not as a single event, but as an ongoing process of renewal. It is both delicate and vast, microscopic in its mechanics, planetary in its scale. The human mind finds comfort in its predictability, the slow pattern of rain against windows, the repeating sound of droplets hitting surfaces, the uniform grey of overcast skies. All of these conditions lower stimulation, leading naturally toward rest. The body responds to the rhythm, synchronizing heart rate and breath to the steady downward pattern. Even without noticing, one begins to slow. It is a physiological echo of the process itself, vapor rising, condensation forming, droplets falling, silence returning. The same rhythm that calms the weather calms the listener. In the context of the universe, rain on Earth is not extraordinary. It is one of countless forms of precipitation that occur under varying conditions of temperature and pressure. What makes it familiar is its accessibility. It can be seen, touched, and heard. Yet its principles, evaporation, condensation, and gravitational descent, apply everywhere. The same laws that guide Earth's weather operate on other planets and moons. They shape methane rain on Titan, diamond rain on Neptune, and metallic rain on distant exoplanets. Each follows the same logic. Particles rise, condense, and fall. As you listen, you can think of Earth's rain as the baseline, the slow, continuous process that prepares the mind for what exists beyond. It is a reminder that even on other worlds, where the air is unbreathable and the rain is strange, the pattern remains the same. The laws of nature do not change. They simply adapt to new materials and new conditions. The sound of falling water becomes the first step in a journey through the quiet rains of the universe. The breath of planets. Every planet holds an atmosphere, whether dense or thin, calm or violent. It is the invisible layer of gases that wraps around a world shaped by gravity, temperature, and time. Some atmospheres are so light that they drift into space, while others press down with immense weight. Each one behaves like a slow, steady breath, expanding, contracting, circulating without pause. It is through this motion that planets exchange energy with the space around them, maintaining balance in quiet and continuous cycles that often last for millions of years. The composition of an atmosphere depends on the planet's location, its distance from its star, and the materials from which it was formed. On Earth, nitrogen and oxygen dominate. making air that supports life and allows water to exist in all its phases. On other worlds, the mixture is different. Carbon dioxide, methane, hydrogen or sulfur may take the place of breathable air, yet they serve the same purpose: to transport heat, to distribute pressure, and to maintain equilibrium between surface and sky. The motion within these gases, though often unseen, is what gives rise to weather. The quiet rearrangement of molecules across a planet's curved surface. Atmospheres do not stay still. Warmth from a star causes gases to rise, while cooler regions draw them downward again. This circulation continues without interruption, forming winds and currents that can last for centuries. On large gas giants like Jupiter or Saturn, the movement becomes layered, with each level of the atmosphere rotating at a slightly different speed. The result is a permanent pattern of calm and turbulence, a slow breathing that reshapes the planet over time. Despite its scale, this motion follows the same physical laws that guide a single cloud drifting over Earth. Some planets breathe quietly, with stable layers of air that change little over long periods. Others breathe violently, with storms so large they could swallow entire worlds. Yet even in their difference, they remain predictable. The circulation follows gradients of temperature and pressure, forming a balance that never stops adjusting itself. On Mars, thin air moves dust across its surface in slow waves, sculpting patterns that stay for centuries. On Venus, the atmosphere is so dense that winds carry its clouds completely around the planet every few Earth days, even as the solid surface below rotates much more slowly. The scale changes, but the principle remains. Gas moves until balance returns. Each planet's atmosphere defines its appearance. The color of a sky, the brightness of a sunrise, the scattering of light, all are shaped by gases and particles suspended within them. Earth's blue sky is a result of molecules scattering short wavelengths of light, while the pale orange haze of Titan comes from organic particles formed under distant sunlight. Neptune's deep blue comes from methane absorbing red light and reflecting the rest. None of these colors are created for beauty. They are simply outcomes of physics, quiet results of molecules interacting with light over time. An atmosphere also determines what can fall through it. Whether a droplet of water, a grain of dust, or a crystal of methane, each must pass through layers of varying temperature and pressure. Some fall easily, others evaporate before reaching the surface. The atmosphere decides the fate of rain. On Earth, it allows water to return to the ground in a steady rhythm. On other planets, it transforms precipitation into vapor before it ever lands, or freezes it into ice that drifts instead of drops. The air itself shapes how gravity is expressed, controlling how fast or slow something falls. To observe a planet's atmosphere is to watch a vast system of exchange. Energy enters from a star, spreads through the gases, and leaves again as infrared radiation. In this process, balance is maintained, even on worlds that seem inhospitable. Every gust of wind, every wisp of cloud, every faint drift of vapor serves a purpose: to equalize temperature and pressure. This movement keeps planets stable across time. It prevents extremes from growing without limit. It is nature's way of distributing motion until stillness can be approached, though never completely reached. In some cases, atmospheres disappear. Small worlds, unable to hold their gases against solar radiation, lose them slowly into space. Mercury, closest to the Sun, has almost none left. Its surface is bare, exposed directly to sunlight and shadow. Other planets, such as Mars, retain only a trace, a thin layer that whispers across its plains but cannot carry sound as Earth does. Even there, faint winds persist, moving dust and shaping dunes. A planet without an atmosphere does not breathe, but it remembers the pattern of those that do, its surface bearing the marks of what was once motion. To understand an atmosphere is to understand time itself. The gases we breathe today are the same that once surrounded the first oceans, the same that cooled volcanic rock and nourished early life. They have changed in composition, but not in purpose. They carry heat, they carry sound, and they carry the faint traces of rain. On distant planets, the air may be made of different elements, yet it follows the same rules: to rise, to fall, and to circulate endlessly. Every planet with an atmosphere, no matter how alien, is engaged in this same cycle of balance. As you breathe now, you are participating in that same process. The air entering and leaving your lungs mirrors the expansion and contraction of gases around planets, stars, and galaxies. Every breath is a small echo of the universe's own rhythm. The line between human respiration and planetary circulation is one of scale, not of principle. Both move in patterns designed for balance. The air that sustains life on Earth is part of a continuum that stretches through the cosmos, joining every atmosphere in a shared, unbroken motion. The breath of planets is not sound, but pattern. It is the invisible tide that maintains the shape of worlds. Through it, storms rise and fade. Clouds form and vanish, and rain begins, not as an accident, but as a necessary result of balance. The same air that carries droplets across the Earth exists in other forms across the universe, guiding rains made of water, methane, or metal, all moving toward rest. The hidden clouds of Venus. Venus, second from the Sun, appears through telescopes as a smooth and bright sphere, covered completely in a layer of golden white clouds. No surface is visible to the naked eye. The planet's true features are concealed beneath an atmosphere so dense that light itself scatters before reaching the ground. From orbit, it looks calm, but within, the air moves with slow power, its circulation wrapping the planet in a continuous pattern of heat and pressure. The clouds of Venus are both barrier and mirror, reflecting sunlight back into space while trapping heat within, creating one of the most stable yet intense environments in the solar system. The atmosphere of Venus is composed primarily of carbon dioxide, thickened by layers of sulfuric acid droplets and fine particles suspended in motionless air. The pressure at the surface is more than 90 times that of Earth, enough to crush metal within moments. Yet above the planet at higher altitudes, the air becomes thinner and cooler. There, between 40 and 60 kilometers above the ground, clouds form continuously. These clouds are not made of water, but of acid, produced by chemical reactions between sulfur gases and what little water vapor remains in the atmosphere. Each droplet that forms begins as a microscopic nucleus, gathering mass until gravity draws it downward. As the droplets fall through the dense layers below, they encounter higher temperatures. The heat increases steadily with depth, and before the droplets can reach the surface, they evaporate. The rain of Venus never lands. It begins in the upper layers of the atmosphere and disappears long before touching the ground. What descends as liquid becomes vapor again, continuing in endless circulation rising and falling in the same motion for centuries. There is no sound of rain, no pattern of droplets striking rock. Only the chemical exchange of gases forming and dissolving in still air. The movement within these clouds is slow but unceasing. Winds high above the surface carry the clouds around the planet once every few Earth days, a phenomenon called superrotation. This circulation contrasts sharply with the rotation of the planet itself, which turns so slowly that one day on Venus lasts longer than a year on Earth. The air moves much faster than the surface below, creating a layered motion that never aligns. From a distance, this produces the illusion of calm, yet beneath it lies an atmosphere in perpetual motion, maintained by the precise balance of heat, gravity, and chemical transformation. Sunlight enters the upper clouds, but very little of it reaches the ground. The thick atmosphere scatters light in all directions, producing a uniform brightness without shadows. The surface of Venus lies in a dim yellowish glow, the result of sunlight filtered through kilometers of gas. The temperature remains constant at more than 400 degrees Celsius, day and night, equator and pole alike. There are no seasons, no weather in the familiar sense, only the slow descent and reformation of droplets in a continuous chemical cycle. The stillness is not emptiness, it is equilibrium, a state maintained by immense pressure and slow transfer of energy. The surface beneath the clouds is rocky, shaped by ancient volcanoes and plains of hardened lava. No rivers flow there, and no winds sculpt dunes. The air near the ground is too dense for movement to create sound. If one could stand there, the world would seem silent. The acid rain above would never arrive, and the heat would blur vision. Yet high above, the clouds would continue their quiet transformations, forming and dissolving as they have for millions of years. The pattern repeats without beginning or end, a planetary heartbeat that moves too slowly for human senses to follow. Venus demonstrates that rain as a process does not require life or oceans to exist. It requires only an atmosphere dense enough for droplets to form, a source of energy to drive evaporation, and gravity to draw the condensed matter downward. Whether the droplets are water, acid, or another liquid altogether, the same cycle repeats: formation, descent, evaporation, and renewal. The clouds of Venus are the clearest example of this repetition. A world where rain exists but never arrives, where the balance between heat and condensation is so perfect that nothing changes its outcome. The presence of these clouds also affects the planet's temperature. The upper layers reflect most sunlight back into space, preventing further heating, while the thick carbon dioxide below traps infrared radiation, keeping the lower atmosphere hot. This dual effect creates stability. The energy entering and leaving remains nearly equal, and as a result, Venus has maintained the same temperature for centuries. The rain that evaporates before falling contributes to this balance by releasing heat as it changes form. Each droplet, though microscopic, plays a role in maintaining the stillness of the entire planet. Seen from far away, Venus glows steadily, its light changing only with its position relative to the sun. The clouds make it one of the brightest objects in the night sky, visible even before darkness is complete. To the observer, it seems peaceful, yet the calm brightness hides a world of slow chemistry, of rain that forms and vanishes in silence. There is no drama in its cycles, no beginning or end, There is only repetition governed by laws that are the same on every planet. Venus teaches that even processes that appear chaotic from a distance, storms, heat or acid rain, follow simple rules of balance. The gases that rise will cool, the droplets that form will fall, the heat that lifts them will return. The cycle continues with mathematical patience, independent of sight or sound. Rain, in this sense, is not a phenomenon of weather, but of equilibrium. It is the universe's way of ensuring that energy moves toward rest. On Venus, this movement has found perfection. The methane showers of Titan. Far beyond Venus, orbiting the giant planet Saturn, lies Titan, a world that moves slowly through the cold outer regions of the solar system. Titan is wrapped in a thick orange atmosphere, dense and hazy, filled with methane, nitrogen and traces of other hydrocarbons. From a distance, it appears opaque, almost like a muted mirror reflecting faint sunlight. Beneath its clouds, however, exists one of the most remarkable and calm systems in nature, a methane-based weather cycle that mirrors the water cycle on Earth. Here, rain falls not as water, but as liquid methane, collecting into lakes and seas that shine faintly under a dim orange sky. The air on Titan is dense enough to hold clouds and winds, but sunlight there is weak. The faint light from the distant sun takes over an hour to reach the surface. As a result, temperatures remain far below freezing, so cold that methane, which is a gas on Earth, behaves as a liquid. It evaporates from the surface of Titan's seas, rises slowly through the thick air, condenses into clouds, and falls again as rain. This process unfolds on a timescale far longer than the weather of Earth. The formation of a single storm may take months, and the fall of rain may last for days without interruption. Everything happens slowly, evenly and predictably, as if time itself moves with less urgency. The methane cycle on Titan is governed by the same principles that control the water cycle on Earth: evaporation, condensation, and precipitation. But the materials and conditions are different. The energy source is weaker, the air is thicker, and the gravity is lower. These differences create a world where the familiar becomes strange. The droplets that form in the upper atmosphere grow larger and fall more slowly. Their descent is cushioned by the dense air, turning each raindrop into a small sphere that drifts rather than falls. When they reach the surface, they merge gently into lakes of methane and ethane, rippling so softly that their movement is almost invisible. On Titan, there are seasons just as on Earth, but they last much longer, more than 7 Earth years each. During the long winter, the poles remain dark and still, while the atmosphere thickens with haze. When sunlight returns, methane evaporates from the surface and begins to gather into clouds again. The clouds drift across the sky, often covering vast areas before releasing their rain. Scientists have observed these changes through spacecraft and telescopes, noting how Titan's sky darkens before a storm and brightens again after the rain. Yet even in storm there is no thunder, no violence, only the slow, steady exchange of energy between air and surface. Beneath this sky, Titan's surface is calm and unhurried. Rivers carved by methane flow toward lakes that cover wide plains. The largest of these, Kraken Mare, stretches for hundreds of kilometers, bordered by smooth shores of icy material. The seas are not turbulent. Their waves are measured in centimeters. The gravity, weaker than Earth's, ensures that motion happens gradually. Even a single drop falling into the liquid takes time to settle, its ripples spreading outward in slow, perfect circles. If one were to stand near such a lake, the light filtering through the haze would be dim and golden, the horizon hazy and the sound non-existent. The rain would touch the surface with barely a trace. Titan's rain is more than a surface event. It shapes the moon's landscape through erosion, just as water shapes mountains and valleys on Earth. Over millions of years, methane rain has carved channels and filled basins, creating a terrain that resembles dry riverbeds seen on our planet. Though here, the liquid remains replenished slowly from the sky. Each droplet contributes to a cycle that has been repeating since Titan's formation. Methane rises, condenses, falls and flows again, maintaining a delicate balance that endures without interruption. Unlike the acid rain of Venus, which vanishes before reaching the surface, Titan's methane rain completes its descent. It nourishes a world that exists in permanent twilight, where the sun is a pale disk and shadows are faint. The light never changes rapidly. Time does not hurry. The air carries no sound but moves in soft currents, transporting molecules of methane and nitrogen through invisible layers. Even the storms, when they occur, unfold in silence, measured not in moments, but in gradual transitions that can be observed only through patient study. For scientists, Titan is a laboratory of calm. It demonstrates that the chemistry of life and weather are not unique to Earth. The same physical laws apply even in the cold and the dark. The methane that falls from its sky behaves exactly as water does here, obeying gravity, temperature, and pressure with perfect discipline. What differs is only the scale and the speed. Where Earth's cycle of rain and evaporation repeats daily, Titans can take months or years. In that slowness, a form of equilibrium is achieved, a world at rest where energy moves but never rushes. The presence of liquid methane also suggests continuity between Titan and the rest of the universe. On Neptune and Uranus, methane exists in gaseous form within deep atmospheres, while on Titan, it condenses into clouds and lakes. The same molecule, behaving differently under different conditions, links these worlds through chemistry and temperature. The result is not variety but unity, the same element participating in endless transformations, as predictable as the rising and falling of rain. As the story of Titan closes, one can imagine the slow descent of methane droplets through its orange air, falling soundlessly toward distant seas. Each droplet reflects faint sunlight, dim and constant, until it merges with the surface below. The pattern never ends and the world remains unchanged in its rhythm. Titan's rain is not violent or expressive. It is steady, patient, and continuous, a mirror of the universe's most enduring principle, that motion and rest are parts of the same process, and that every fall is simply a return to balance. The diamond rain of Neptune and Uranus, far beyond Saturn, where sunlight fades to a pale echo and temperatures fall hundreds of degrees below freezing, two distant planets drift quietly in their long orbits. Neptune and Uranus, known as the ice giants, move in calm parallel paths around the Sun. Their atmospheres are deep and cold, layered with hydrogen, helium, methane, and traces of other gases. From a distance, they appear soft and luminous. Neptune with its deep, steady blue, Uranus with its pale, muted tone. Though they seem peaceful and still, inside their vast atmospheres, a slow and extraordinary process unfolds, one that turns the invisible into the solid, the formation of diamond rain. The idea of diamonds falling through a planet's interior might sound improbable, yet it follows simple and measurable physics. In the upper layers of these planets, methane exists as gas, stable and quiet. But deeper down, as pressure increases, the bonds within the methane molecules begin to break. Carbon atoms separate from hydrogen and drift downward. Under conditions of immense pressure, millions of times greater than the air at Earth's surface, and temperatures thousands of degrees high, those carbon atoms compress into a dense, crystalline form. This is diamond, created not in eruption or fire, but in slow, methodical transformation. The diamonds that form within Neptune and Uranus are not like the ones found on Earth's surface. They are born not through volcanic eruption, but through the weight of atmosphere pressing endlessly from above. At a certain depth, where temperature and pressure reach perfect balance, layers of solid carbon begin to condense. These layers grow heavier, and the crystals fall slowly toward the planet's cores. It is rain, though not of liquid, but of solid matter descending through thick clouds and hot layers of compressed gas. The diamonds drift downward for thousands of kilometers, melting again as they reach regions too hot for their structure to survive, completing a cycle that repeats eternally within the hidden depths. This rain cannot be seen directly. It has been inferred through experiments and models, tested in laboratories where scientists recreated the same high pressures using lasers and shock waves. In these controlled conditions, methane gas was found to break apart, releasing carbon that quickly arranged itself into diamond. The experiments confirmed that under the right balance of heat and pressure, the same that exists deep within Neptune and Uranus, diamond formation is inevitable. What falls there is not fantasy, but chemistry in its most patient form. Inside these planets, time moves differently. The outer atmosphere rotates at a moderate speed, with winds flowing at hundreds of meters per second. Yet below that motion lies immense stillness. The transition from gas to solid occurs slowly, without turbulence, each atom aligning itself according to laws that require no supervision. The descent of carbon crystals continues endlessly, a slow rain that may last for billions of years. Nothing interrupts it, for the planets are stable, their internal energy flowing outward in steady gradients. The diamonds do not fall in storms. They fall in silence, under constant pressure, guided by gravity's unchanging pull. The diamond rain of Neptune and Uranus plays a role in the structure of the planets themselves. As the crystals sink, they release heat through friction and recombination, warming the interior layers. This heat contributes to the slow convection that moves gases upward again, completing a deep, invisible circulation. Energy flows outward, carbon falls inward, balance remains. The planets cool only gradually, maintaining their temperature through this quiet exchange of motion and transformation. What might seem still from afar is in truth a cycle of constant, measured change. In the upper layers of Neptune, where sunlight still reaches, methane reflects the short blue wavelengths of light, giving the planet its distinct color. Beneath that serene surface lies a field of transformation so powerful that it reshapes matter itself. The blue glow of the planet hides an interior of heat and compression, where diamonds form, fall, and vanish. The contrast between appearance and reality is not contradiction but continuity. The outer calm depends on the inner movement. Stability above is maintained by activity below. just as clouds on Earth are sustained by the evaporation and condensation happening invisibly in the air. The concept of diamond rain connects the distant giants to familiar processes on Earth. Both are forms of precipitation driven by pressure and gravity. The difference lies only in scale and material. On Earth, water vapor condenses into liquid droplets that fall and return. On Neptune, methane decomposes into solid carbon that falls and transforms. Both processes illustrate the same universal rule. When energy seeks balance, matter changes state, and that change produces descent. The same law that makes rain fall on Earth makes diamonds fall within Neptune's clouds. The stillness of these planets is deceptive. They do not move quickly, and their orbits take centuries to complete. Yet within their quiet layers, motion never ceases. Carbon atoms shift positions. Pressure builds. Diamonds form and dissolve again in cycles so slow that a single crystal's journey from formation to melting might last longer than all of human history. Nothing in this process is chaotic. Each stage follows from the last with perfect order, guided by the unchanging principles of thermodynamics and gravity. When imagined as sound, the descent of diamonds would be silent. The atmosphere there is too dense for noise to travel freely, and the fall is too gradual to create disturbance. The crystals sink as though through liquid, surrounded by layers of gas so thick they behave almost as a fluid. The fall is endless, the pattern unbroken. From above, no light penetrates that far. From below, no heat escapes easily. The rain of diamonds becomes part of the planet's identity, unseen but continuous, shaping its temperature, structure, and balance. In this deep stillness, the universe shows one of its quiet truths. Even the most extraordinary phenomena occur without spectacle. The falling of diamonds through a planet's interior is governed by the same calm equations that describe a droplet of rain sliding down a window. The scale differs, but the principle remains identical. The movement of matter from higher to lower energy, the return to equilibrium, the conversion of motion into rest. Neptune and Uranus are reminders that beauty and drama are not requirements for significance. What happens slowly, invisibly, and without sound is still part of the same universal rhythm that governs all motion. The metallic rains of exoplanets. Beyond the boundaries of the solar system, circling distant stars that appear only as faint points of light in the night sky, exist worlds so close to their suns that their skies glow with vaporized metals. These are the hot exoplanets, places where temperatures rise above 2000 degrees Celsius, and the air itself becomes a field of chemical reaction. Some of these planets orbit so near their stars that they complete a full year in only a few Earth days. The heat is steady, unbroken, and immense, yet even here, under such conditions, rain still falls. Not as water, not as methane, but as molten metal condensing in the cooler regions of the atmosphere and drifting downward in silence. Among these planets, one has drawn special attention. It is called WASP 76b, a world so close to its parent star that its day side faces the light continuously, while its night side remains in permanent darkness. The difference between those two halves is extreme. The side facing the star reaches temperatures where iron, magnesium, and other metals turn to vapor, rising slowly into the air like mist. High above, winds carry these vapors across the boundary between day and night, where the heat begins to fade. There, in the cooler twilight, the metal condenses again, forming droplets that fall back toward the surface. It is rain made not of water, but of iron, falling in a steady drizzle that no eye has ever seen, but whose presence is written in the light that reaches telescopes on Earth. The process is mechanical and calm. Heat drives evaporation, cooling drives condensation. The droplets that form are heavy, dense and metallic. They fall through thick air guided by gravity in the same way that water falls through the atmosphere of Earth. When they descend into warmer layers again, they vaporize, returning to the upper atmosphere once more. This cycle repeats endlessly, vapor rising, condensing and falling, maintaining equilibrium between heat and coolness, between motion and rest. Even under extreme conditions, the universe follows the same gentle pattern. Matter adjusts until balance is restored. Scientists study these distant worlds by observing the faint variations in light as the planets pass in front of their stars. The starlight, filtered through their atmospheres, reveals the fingerprints of the elements within: sodium, magnesium, iron, and other metals drifting in vapor form. The readings confirm that, despite their heat, these planets experience weather. Not storms of water or ice, but slow cycles of metallic condensation and evaporation. The term rain applies here not in the human sense, but in the physical one, material moving downward under the influence of gravity, returning energy to the lower layers of the atmosphere. Other exoplanets show similar behavior. On HD 189733b, the sky may contain droplets of silicate, particles of glass, suspended in clouds and falling as transparent grains when conditions allow. The surface wind speeds reach thousands of kilometers per hour, yet the movement of these particles remains steady. The glass forms, falls and melts again, each cycle taking place with quiet precision, following temperature gradients as naturally as water does on Earth. Though these processes occur far away, across unimaginable distances, their rhythm is identical to that of every planet's weather. The material differs, but the balance remains the same. In such environments, the definition of rain expands. Precipitation becomes a universal act, not limited to water or life, but to any substance that can shift between gas, liquid, or solid. The principle is one of repetition, not substance. Whether the droplets are molten iron, liquid methane, or diamond dust, they follow the same unbroken sequence of transformation. Heat causes lifting, cooling causes falling, and gravity ensures return. The difference between a soft drizzle and a metallic storm is only one of temperature and scale. The laws that guide them do not change. The rain on these exoplanets would not make sound as it does on Earth. The air is dense, hot, and turbulent, and noise cannot travel in the same way. The droplets of iron or glass would fall quietly, absorbed into the fluid-like layers of gas beneath. No flash, no spark, no thunder. Only the slow descent of matter under gravity's constant pull. The image of this process is not one of chaos, but of precision. Atoms combining, separating, and recombining according to predictable rules that remain unchanged no matter the world. The study of these planets has expanded the definition of weather itself. Where once rain was thought to belong only to Earth and its nearby neighbors, it is now known to exist wherever temperature and pressure allow change of state. It is not limited to any element or distance. Every planet, every moon, every gaseous sphere may hold its own version of precipitation. each one participating in the same slow cycle of transformation. The universe, through this repetition, maintains thermal balance across countless environments, ensuring that energy continues to move from high to low, from heat to rest. The metallic rains of exoplanets reveal something profound about continuity in nature. Even in places where temperatures melt rock, the same delicate process of condensation occurs. Even where no water exists, droplets still form, fall, and vanish. The patterns are universal. The details change, but the equation remains the same. It is the universe's quiet handwriting, visible in every sky, whether of iron, glass, or vapor. From the perspective of time, these rains have been falling for millions of years. The stars around which these planets orbit are old, their light reaching Earth only after traveling through space for centuries. The metallic clouds we observe now may have formed long before human history began, yet they continue, undisturbed, repeating the same process under the same rules. There is no urgency in their motion. Each droplet falls, evaporates, and forms again, part of an endless conversation between heat and cold, energy and stillness. In this way, the metallic rains of distant exoplanets are not strange. They are familiar, governed by the same physics that cause a single droplet of water to fall here on Earth. The materials differ, but the rhythm is shared. Rise, condense, fall, return. Even across galaxies, the quiet equilibrium of rain continues, linking worlds in the same universal motion toward balance. The invisible rains, snow, vapor, and dust. Not all rain falls as liquid. In many worlds, the atmosphere is too thin, too cold, or too faint to allow droplets to form. Yet gravity still draws particles downward, and condensation still occurs wherever temperature and pressure meet in balance. These quiet, unseen forms of precipitation, snow that drifts like dust, vapor that settles like mist, minerals that fall grain by grain, remind us that the act of falling is universal. Across the solar system and beyond, countless forms of invisible rain move continuously, unnoticed, silent, and steady. On Mars, the air is thin and dry, its pressure less than 1% of that on Earth. Clouds form there from carbon dioxide and water ice, but they rarely produce full raindrops. The atmosphere is too fragile to hold them together. Instead, the water vapor condenses into tiny crystals that drift downward like faint dust, evaporating before they touch the ground. Near the poles, where the air grows colder, carbon dioxide itself freezes from gas to solid, falling as dry ice snow. Each grain is microscopic, carried gently through the air before returning to the surface to become part of the polar caps. The cycle is almost invisible, continuing year after year, each winter replenishing what the summer light removes. Farther from the sun, Pluto lies in near permanent darkness. Its atmosphere is delicate, composed mainly of nitrogen with traces of methane and carbon monoxide. When sunlight reaches it, even from such a great distance, the faint heat causes surface ice to sublimate, to change directly from solid to gas. The vapor rises slowly, forming a thin haze that circles the dwarf planet. When the temperature drops again, the vapor condenses back to frost, falling quietly onto the frozen ground. There are no clouds, no liquid, no sound. Only a continual exchange between solid and gas, a gentle breathing that takes decades to complete. On moons without atmospheres, the process continues in different form. Without air, there can be no droplets, but there can still be descent. Fine dust, disturbed by impacts or by the faint push of solar radiation, drifts downward under the pull of gravity. Over time, this dust coats every surface, forming a soft layer that thickens with each passing century. On the moon, for example, this dust, called regolith, settles from tiny fragments broken by meteorites. Each grain falls at its own pace, unaffected by air resistance, its motion perfectly uniform. It is not rain as we know it, yet it follows the same law. Matter falling toward rest. Some worlds experience invisible precipitation through vapor rather than solid matter. On icy moons like Europa and Enceladus, heat from beneath the surface sends plumes of water vapor into the thin atmosphere. As the vapor cools, it falls back as a fine frost, settling evenly across the surface. This process repeats endlessly, covering the icy crust with a thin, reflective layer that hides oceans below. To the human eye, it would look like nothing at all. No clouds, no wind, only stillness. Yet under that stillness, the same mechanism operates: evaporation, condensation, and return. In certain distant exoplanets, this invisible precipitation takes forms that exist beyond direct observation. Some may have clouds made of silicate dust, where microscopic particles drift for months before settling. Others may produce snow made of ammonia or methane, falling so slowly that a single flake might take hours to reach the ground. The temperatures are low, but the process is constant. Condensation creates form. Gravity creates motion. Every particle moves toward balance, following a pattern that has no beginning and no end. Even in the absence of atmosphere, the principle of precipitation remains valid. Wherever particles can form, gravity ensures they will descend. The process does not require life, sound, or light. It requires only the quiet relationship between energy and matter, cooling leading to condensation, condensation leading to fall. This interaction occurs everywhere, from the dense layers of Neptune's clouds to the airless plains of asteroids. The forms differ, but the result is the same: descent, rest, renewal. These invisible rains shape landscapes slowly. The frost that settles on Pluto brightens its surface, reflecting sunlight back into space. The dust that drifts across Mars fills valleys and smooths craters. The frozen vapors on Europa and Enceladus preserve traces of chemicals from below, carrying messages from hidden oceans to the outer ice. Though the movements are small, they accumulate over eons, carving, covering, and softening the surfaces of worlds. There is no rush in this process. It is measured in geological time, each grain or crystal marking another moment in the long rhythm of planetary evolution. The invisible rains also influence temperature. As particles condense, they release heat. As they sublimate, they absorb it. This exchange keeps even the coldest worlds in subtle equilibrium. It is the same process that governs the weather of Earth, slowed to the scale of frozen eternity. Where the atmosphere is thin, the balance is delicate, yet it persists. Nothing in the universe stands completely still. Even the faintest vapor finds motion. Even the smallest grain seeks the ground. To imagine these rains is to think in scales too large and too small for daily experience. Dust settling across a crater over millions of years, frost building a single layer of ice that endures for centuries, a snowflake drifting silently in air so thin it almost floats forever. Yet every one of these acts, slow and quiet, is a reminder that gravity never rests. The universe is always drawing matter toward balance, whether it is water on Earth, diamonds on Neptune, or vapor on Pluto. Invisible rain is, in its way, the most common form of precipitation in the cosmos. Most worlds do not have the pressure or warmth for liquid droplets to exist. Instead, they express the same process through vapor, snow, or dust, repeating the same pattern across billions of kilometers. The absence of visibility does not mean absence of activity. The universe continues to fall, quietly and continuously, through every layer of existence. The universal law of falling. Everything that falls in the universe does so for the same reason. Whether it is a drop of rain on Earth, a diamond crystal inside Neptune, or a grain of dust settling across a crater on the Moon, the motion is governed by one principle: gravity. Gravity is the quiet architect of order. It is not seen, yet it defines the structure of galaxies, the paths of planets, and the descent of a single particle through air. It does not rush or hesitate. It acts steadily, drawing matter toward the point of least energy, toward the state of rest that every system seeks. The law that guides this motion is universal. It applies equally to the smallest and the largest scales. On Earth, it pulls rain downward through the atmosphere, each droplet following a curved path determined by air resistance and weight. On the Moon, it draws dust directly to the ground in silence. Around stars, it binds planets in their orbits, holding them in balance between motion and fall. On galactic scales, it gathers clouds of gas, forming stars that will, in time, release the same materials that later fall as rain on planets. Gravity is the common thread linking formation, movement, and rest. When a droplet begins its fall, it accelerates until the upward pressure of air equals the downward pull of weight. At that point, it reaches terminal velocity, a stable speed where forces balance perfectly. This moment of equilibrium, though small, repeats endlessly across the universe. The same balance holds moons in orbit and shapes the slow inward drift of matter around black holes. Everywhere the story is the same. Energy seeks balance and gravity provides the direction. The form of falling may differ: liquid through air, solid through gas, or dust through vacuum, but the law remains identical. In this law there is no conflict. Nothing resists gravity. It only follows its gradient. The curve of space around mass directs every path, ensuring that what begins in motion eventually settles. The pace depends on scale. A raindrop may fall for a few seconds. A planet may orbit for billions of years before collapsing inward. A galaxy may drift slowly toward its neighbors across cosmic time. Each fall completes the same act of return, the conversion of potential energy into stillness. The universe itself unfolds through this process, expanding outward yet held together by the attraction that never ceases. Even light, which travels at the fastest known speed, feels the influence of gravity. Near massive bodies it bends, following the curvature of space. The path of a photon passing near a star is not straight, but slightly curved, obeying the same rule that draws a droplet toward the ground. The difference lies only in degree. The motion is not forced but natural, shaped by the geometry of space-time itself. This bending of light, observed countless times, confirms that falling is not an action imposed from outside, but a property of the universe's structure. The presence of gravity ensures that rain, in whatever form, always finds a destination. On Earth, water gathers in rivers and seas. On Titan, methane collects in lakes. On Neptune, carbon crystals sink until they melt again in the heat below. Even dust on airless moons accumulates in depressions, following subtle curves of terrain. Every descent ends in contact. Every journey concludes in rest. The surface, the core, or the horizon becomes the point where motion ceases, but the law remains unchanged. When conditions shift, evaporation or energy input begins the process anew. Gravity is not constant in strength, yet its behavior is constant in pattern. On small planets, it feels light and allows objects to drift slowly. On giants, it presses down with great force, compressing matter into new forms. The variation in its intensity gives shape to diversity. Gentle rain here, diamond storms there. But the underlying motion is shared. Every particle in every corner of space obeys the same directive. This unity of motion is what gives the universe its coherence. Without gravity, there would be no rain, no orbit, no structure. This law also links the microscopic and the vast. A molecule of water, cooling in the upper atmosphere, begins to fall in response to the same geometry that keeps galaxies in rotation. The connection between them is mathematical and precise. Each follows the shortest path through curved space, each moving toward lower potential energy. This harmony of scale gives the cosmos its stability. From droplet to star, from grain to planet, everything descends according to the same equation, the same quiet tendency toward equilibrium. The law of falling is not a rule of destruction, but of completion. It transforms height into rest, energy into structure, motion into order. Without it, matter would drift aimlessly, unable to form planets, clouds, or rain. With it, the universe maintains its rhythm. Things rise through heat or force, then return through cooling or weight. The return is inevitable but gentle, an ongoing correction that brings balance. Gravity's work is invisible but endless, ensuring that nothing remains separate for long. To think of rain in this context is to understand it as part of the same universal motion. A droplet falling from a cloud is not isolated. It participates in the same dynamic that holds the stars in their orbits. The act of falling connects everything: sky to ground, surface to core, light to darkness. Every descent, no matter how small, is part of a greater cycle that moves the universe towards symmetry. It is not a fall of loss, but of restoration. The droplet that reaches the sea, the diamond that reaches Neptune's center, and the dust that settles on Mars all obey the same unbroken pattern of return. When described slowly, this law becomes a kind of stillness. It is not about motion itself, but about inevitability, the assurance that all things find rest, that every ascent meets its descent, and that no energy moves forever without direction. The universe breathes through this process, expanding and falling, rising and settling, in cycles that echo through all scales of time. Rain is only its smallest expression. The act of falling is its language, written in every drop, every particle, every orbit. It is the same word, repeated endlessly across space: balance, the return to Earth, and the sleep of worlds. After traveling through distant planets and strange forms of rain, the mind returns quietly to Earth, the world where the idea of falling first became familiar. Here, rain continues to trace its endless patterns, moving from sea to sky, from cloud to soil, from vapor to droplet and back again. The air carries moisture as gently as it carries sound, spreading calm through invisible motion. Every raindrop that forms follows the same rhythm that governs entire planets, proving that the vastness of space and the simplicity of weather are not separate, but connected through the same calm order. When the first clouds gather, they form without urgency. Warm air rises from the surface, carrying vapor upward until the cooler atmosphere invites condensation. The droplets combine and grow heavy, beginning their slow descent. Each drop follows a path shaped by gravity and resistance, adjusting to temperature and pressure as it falls. On the ground, it joins countless others, feeding rivers, filling lakes, or soaking into the soil. There is no sound of effort in this movement, only the faint repetition of contact. Water meeting earth, air meeting water, energy finding rest. This process, repeated endlessly, is part of the same balance that governs all things. The clouds release their weight, the surface accepts it, and in time the cycle reverses. Evaporation lifts water once more into the air, and the pattern renews itself. From a distance, it may appear monotonous, but this repetition is the reason the planet remains alive. The constancy of rain cools, nourishes, and stabilizes the world, keeping oceans and land in perpetual conversation. The same molecules that fall today may have once drifted as vapor thousands of years ago, or fallen as snow upon ancient mountains, or flowed quietly into the sea. The listener, resting now, is also part of this same rhythm. The air that moves through the lungs once passed through leaves, oceans, and clouds. Each breath mirrors the exchange between atmosphere and surface, an echo of the planet's larger circulation. The body at rest participates in the same laws that shape the orbit of the moon, the tides of the seas, and the fall of every drop of rain. In stillness, there is no separation between self and environment. There is only one continuous motion of matter, seeking equilibrium. Across the cosmos, the same laws continue to act in silence. Methane falls on Titan, diamonds drift inside Neptune, molten iron condenses on WASP 76b, and frozen vapor settles on Pluto. Every form of rain, visible or invisible, hot or cold, fast or slow, expresses the same principle. The movement of matter toward balance under gravity's patient guidance. These rains differ in substance, but not in meaning. They are all instances of the same universal rhythm, the same quiet correction that maintains harmony among worlds. Back on Earth, that rhythm can be heard in the soft tapping of droplets against surfaces, in the consistent repetition of sound that neither hastens nor fades. The pace of rain slows thought, aligns breath, and draws the mind toward stillness. The listener begins to follow that rhythm without noticing, each heartbeat settling into the same gentle pattern. Awareness narrows until only sound remains. Then even sound begins to dissolve into silence. The rain continues, but perception fades into its cadence, as if consciousness itself were part of the falling. Through this pattern, one may sense the unity of movement that connects the smallest droplet to the largest orbit. Nothing in the universe is separate from the act of descent. Planets turn because they have fallen into motion around stars. Stars shine because matter has fallen inward to ignite. Clouds rain because vapor cools and falls. Sleep comes because energy within the body settles, obeying the same invisible gradient toward rest. Falling is not failure, it is resolution, the inevitable return to equilibrium that gives shape to existence. As the rain outside slows, the air grows heavier and the sound becomes more distant. The listener too begins to sink toward rest. The body, once alert, follows gravity's pull into stillness. The thoughts that once moved quickly through the mind drift downward, their weight increasing until they disappear into the soft equilibrium of sleep. The world narrows to rhythm. Breath in, breath out, rise, fall, cloud, rain, motion, rest. The distinctions between them blur, leaving only continuity, the same quiet balance that governs planets, oceans, and stars. In this stillness, nothing ends. The rain that falls tonight will rise again tomorrow. The energy that fades in one place reappears in another. The cycle of condensation, descent, and evaporation mirrors the movement of galaxies, expansion followed by contraction, motion followed by pause. The universe does not stop. It breathes. Every world, every droplet, every thought participates in that breath. In this understanding, rest is not absence, but participation in the wider rhythm that sustains all things. The listener lies now within that rhythm, part of the same structure that governs the stars and the falling rain. The sound becomes faint, like memory. The body is still, the air calm, the mind silent. Gravity, time, and breath act together in quiet harmony. The cycle of falling continues, but awareness drifts away from it, merging with the stillness that underlies all motion. The universe, in its endless balance, continues to fall, softly, endlessly, patiently, and within that falling, the world sleeps.